26, problem 26, they say in triangle ABC, JB and KA are medians. So JB is this, KA is this. If those are medians, that means K and J are midpoints. So we know these two segments are congruent. We know these two segments are congruent. They tell us that segment JK, that's this segment right here, is 10x minus 12. And that's a mid segment because it connects two midpoints. They tell us that segment AB is 9x plus 18. That's the bottom side of that triangle. We had a theorem that said that this mid segment has to be half as long as that. So two different things we could do. We could take the mid segment and double it to get this length that this segment on the bottom should be. Or we can take this and take half of it to get the length that the mid segment should be. It's probably easier this time because I don't want to take half of 9. That gives me 4.5. That would be a little harder to work with. So it's probably easier just to take this and double. So I'm going to take 2 times 10x minus 12. And that equals 20x minus 24. Well, when I double that, that should be the same as this bottom side. So 20x minus 24 should equal 9x plus 18. Once I have that, now I can solve for x. I'm going to subtract 9x on both sides. End up with 11x minus 24 equals, these cancel out, equals 18. Add 24 to both sides. I end up with 11x equals 42. I'm going to rewrite this up here because I'm running out of space. 11x equals 42. I'm going to divide by 11. 11 is not going to go into 42 evenly. So you'll notice down here they say round your answer to the nearest 10th. So they knew it wasn't going to come out evenly, so you just take 42 on your calculator, divide by 11. Nearest 10th means we want to go out 1 decimal place. And it says 3.81. So the 1 tells us to leave the 8 the same, so x equals 3.8. Once we know x is 3.8, we're going to take that, and they want us to find the length of segment JK, which is that mid segment, and segment AB, which is this side of the triangle, and we're going to plug in. We really only have to plug into one or the other, because the mid segment is always going to be half as long as this side, and this side is always going to be double what the mid segment is. So I'm going to plug into this one. 10 times 3.8 minus 12. You do that. Plug that into your calculator, do the math. That's going to tell you how long segment JK is. And then to find segment AB, you're just going to take the answer that you got here for JK when you did this math, and you're going to double. So you times this answer by 2, and that's going to tell you how long segment AB is. So you can put those in. Next one says find the perimeter of triangle ABC. Triangle ABC is the big triangle here. So we're trying to find the perimeter of all of that. Well, you just found out how long segment AB was. That's going to be part of that perimeter. So whatever you found for segment AB right here, that's what you're going to put right here. Then we also want segment BC and segment AC. If I go back up here to the problem, they tell us that segment JM, that's this one in here, is 21. That doesn't really help us for now. Segment KM, that's from here to here, is 23. That doesn't really help us for now. Segment AJ, from here to there, is 60. that does help us because we knew that these two segments had to be congruent. So if that's 60, that has to be 60. And then segment BK is 52, so that's right there, that's 52. And we also know that this segment and this segment have to be the same. So if one's 52, the other's 52. So we're gonna add up these. That's gonna give us BC plus these two, that's gonna give us AC. We add up all of those. This one you got on the first part of the problem. This one we can find for BC, we can find right here by adding 52 and 52. This one, AC, we can find by adding 60 and 60. And then that's going to give you your answer, which is the perimeter of the bigger triangle. Then it says find the perimeter of triangle ABM. Triangle ABM is this triangle that's down here on the bottom. ABM, that's this triangle. Well, they told us that this little segment right here was 21. And we know that point M right here, since this is a median, that's a median, point M's got to be the centroid. And if that's 21, then from M to B has to be double that, which is double 21 is 42. And then from M to A has to be double this segment over here, which was 23, so that's 46. So to find that perimeter of this triangle, we're going to add segment AB, which you found up here in number 1, or in part A, I mean, plus 46 plus 42. And whatever that total gives you, once you find AB, that's going to be your answer for part C there. Next one, same idea. They tell us that JB is a median. That means this is a midpoint. These two are congruent. They tell us that segment KA is a median. So that means these two are congruent. And that also means that this is a mid segment, so it's half as long as this side down here. They tell us that JK is 10x minus 14. They tell us that segment AB down here is 7x plus 20. Same idea, we could take half of this, and it should be the same length as that, or we could double this, and it's going to be the same as that. Again, it's probably going to be easier to double this one this time. So we're going to take 2 times that, so 2 times 10x minus 14, which equals 20x minus 28. Well, that length, doubling this, should equal this down here. So 20x minus 28 should equal 7x plus the 20. And we're going to solve here, subtract 7x on both sides, end up with 13x minus 28 equals 20. Add 28 to both sides, end up with 13x equals 48. Again, I'm going to rewrite this up here. That's 13x equals 48. I'm going to divide both sides by 13. Grab your calculator. 48 divided by 13. And this time it equals 3.69. We want to round off to the nearest tenth, so 1 decimal place. So 3.69 is going to round to 3.7. Once I know x is 3.7, I can plug in here 10 times 3.7 minus 14. That's going to tell you the length of segment JK. And once you find JK, you double it, and that's going to tell you the length of segment AB. Same idea on all this. If we go down here, they tell us BK is 31. Well, if this is 31, then this has to be 31. And you're going to do the same thing that we did on the other problem. Segment AJ is 34. Then you can find segment JC. And we're going to add up this whole side, and this side. And that's going to tell us the perimeter of the big triangle. Then they also tell us that segment JM is 11. That's this little segment right here. Well, this one has to be double that. So you can find the length of segment MB, which is one of the sides that we need down here. And then they tell us that segment KM is 15. So this little part right here is 15. Well, this has to be double that. That's segment AM. That's another side that we need to find the perimeter of this bottom triangle. And then we already know segment AB. We add those three up. We'll find AB up here in our first answer. We add those three up, and that's going to give us the perimeter of this bottom smaller triangle. 28. For an art project, you need to create a design that involves only triangles. One of the triangles you cut out is shown below. List the angles ABC in order from smallest to largest. So we want to list the angles from smallest to largest. Remember, the smallest angle is always across from the shortest side, and the longest angle is always across from the largest side. Or the biggest angle is always across from the longest side. So we look at this is the smallest side. So it's across from angle A. The next side, the middle side, is that one. And it's across from angle B. And then the 20 is the biggest side, and it's across from angle C. That's your list. That's what should be in your blank. Going from smallest to largest. Make sure you're using your symbols. Next one's same idea, except this time they say largest to smallest. So we want the largest. Well, that's the longest side, so that has to be the largest angle, and I'll let you list out the angles this time. This is the next longest side, so that has to be the next biggest angle. And this is the smallest side, so that has to be the smallest angle. So list them from largest to smallest. Make sure you're using your angle symbols. Next one, triangle has two sides that measure 9 inches and 27 inches. Describe the possible lengths of the third side. Easiest way to describe these is we said you put the third side in the middle and you do the two alligator mouths, less than. To find this side over here, we subtract the two sides that they give us. Over here, we add the two sides that they give us. The two sides they give us are 27 and 9, so 27 minus 9. That's going to give you the lowest it could be. Over here, we add 27 plus 9. That's going to give you the highest. And then you just write it. Third side, whatever this over here is, whatever number that is, whatever number that is. And it's telling you, if you want to write it out in words, it's telling you the third side of the triangle has to be between whatever number you put right here and whatever number you put right there. Is it possible to construct a triangle of lengths 35, 23, and 62? If not, explain why not. So on this, when we're checking this to see if it's possible for those three to make a triangle, we pick any two sides, and they have to add up to be more than the third side. And you have to check them all. Unless you get one that doesn't work, then it can't be a triangle and you can stop right there. So if we pick 35 plus 62, that should be bigger than the third side, which is 23. And it is. 35 plus 62 is 97, that's bigger than 23. But then if we pick 35 plus 23, that should be bigger than 62. Well, 35 plus 23 is 58. 58 is not bigger than 62. So our answer here would be no, it can't be the size of a triangle, and the reason would be 35 plus 23 is not larger than 62. Next one, they say XD and YD are congruent, so we're going to mark those as congruent. They tell us XF and CF are congruent, so we'll mark those as congruent. And then they tell us YE is congruent to EZ. So that means each of these is a midpoint, and each of these is a mid-segment. And our theorem about mid-segment said this mid-segment is half as long as this side of the triangle, and it's also parallel to that side of the triangle. So we look at this, and we got segment DE right here is parallel to, that's going to be this side, segment XZ. So that's what goes there. Now I'm not going to tell you all these answers, I'll show you as I go through it, but you need to be able to write them over here in the blanks. Then XY, that's this segment, is parallel to, well, it's going to be parallel to that segment. So you should be able to name it with the two letters and make sure you're using your segment symbols. DY, that's this segment, is congruent to, well, this segment, DY, is going to be congruent to this segment because we know D is a midpoint, but then we also know that those two are both congruent to that segment. So we could put one tick mark on that. So DY is congruent to this segment and it's congruent to that segment. You could write those in both over there. And along those same terms or same ideas for DF, DF is right here. Well, we know it's half as long as this side, so these two and DF are all three congruent. So those are going to be your two answers that go over there. Then they ask you DF is parallel to which side? Well, it's going to be this side right here. Name it with just the two letters Y, Z. That's going to go right there. In the diagram, the formal garden, the east and west path is perpendicular to the north-south path. So they're saying that this comes down here and it forms a right angle, perpendicular, and segment AD is congruent to segment CD. So this segment that comes down through here, this path that runs through there, is the perpendicular bisector of segment AC. Well, we had a theorem that said any point, no matter where it's at on here, on the perpendicular bisector is the same distance from A as it is from C. It's the same distance from the two endpoints of the segment. Well, B, we already have one there, so it's the same distance from A as it is from C, so that tells us these two have to be congruent. And it says, what can you conclude about segment AB and segment CB? Well, what we can conclude, and I'm not going to write it all out, you can write it out if you're listening. Segment AB and segment CB have to be congruent, and our explanation would be because B is on the perpendicular bisector of segment AC, and any point on the perpendicular bisector has to be the same distance from the endpoints of the segment. The diagram shows fire hydrants located at points A and B. Line PQ coincides with Tonk Road and is the perpendicular bisector of this segment. Will a firefighter at the scene of the car fire have to walk farther to connect the hose to hydrant A or hydrant B. So the car fire is there. They said that this is the perpendicular bisector of segment AB here. They want to know, does he have to walk farther to A or to B? Well, if this is the perpendicular bisector and P is on the perpendicular bisector, then he doesn't have to walk farther to either one. So our explanation would be the two distances are the same because P is on the perpendicular bisector, and any point on the perpendicular bisector has to be the same distance from A as it is from B. Next one. When a king truss is built correctly, point P lies on the bisector of angle ACE. So point P, they're saying here, should lie on the bisector of this angle. So these two angles should be congruent if they build it correctly. How can a carpenter use the supports PB and PD to make sure that P is in the correct position? Right, so what we can do here, this is an angle bisector. This comes down through here, and that's still P there. If this comes down through here, it's an angle bisector. Then any point that falls on that angle bisector should be the same distance from this side of the angle as it is from that side of the angle. So as long as we have right angles here, these two supports must be the same length. So he makes these two supports the same length, and he knows that this is the angle bisector, then he'll know that this truss is built correctly. Problem 40. You and your two of your friends deliver newspapers in the neighborhood. The newspaper distributor wants the pickup box to be the same distance from each person's house. Explain how you can use the diagram to locate the pickup box. So this is your friend's house, this is your friend's house, this is your house. We have a triangle here. And what they want is they want to put a box in here somewhere that's the same distance from your house as it is from that friend's house as it is from that friend's house. So they want all three of them to be the same distance. So what we're doing here is we're figuring out that point that's the same distance from the corners of the triangle. So what you're going to look up, there's two things that we talked about. You had the in-center theorem, and you had the circumcenter theorem. One of them said that either the in-center or the circumcenter is always the same distance from the corners of a triangle. So you're going to look up those two theorems, and whichever one it is that's the same distance from the corners of a triangle, that's going to be your explanation here. You're going to use that theorem and say the blank is always the same distance from the corners of a triangle. So look up those two theorems and use that to explain your answer. Next one says, you are drilling a hole in the triangular birdhouse shown. You want the hole to be the same distance from all three sides. Where should you drill the hole? Same idea on this one. In-center theorem or circumcenter theorem. One of those two theorems talks about either the in-center or the circumcenter being the same distance from the sides of the triangle. This time, instead of being the same distance from the corners of the triangle, it's the same distance from the sides of the triangle. So figure out which theorem it is, and that's going to help you with your explanation for what do you need to do here. Do you need to find the in-center, or do you need to find the circumcenter? And your reason is going to be because it is always the same distance. That point, whether it's in-center or circumcenter, is always the same distance from the three sides of the triangle. Landscaper wants to plant magnolia tree in the triangular courtyard shown so that the tree will be the same distance from all three boundary lines. These are your boundary lines, boundary segments actually, but same idea. So you want to plant a tree in here, and you want it to be the same distance from here as it is from here as it is from here. Well, that's the same thing as this one up here. Your same distance from the three sides of the triangle. So that's going to help you explain this when you figure out whether it's the in-center or the circumcenter, which term you're using. 43 says the diagram shows a piece of wood for one side of a shelf. So this is the side of the shelf that you're making. Point P is the center of a hole for a dowel rod that is to be drilled 5 centimeters from sides A, B, and segment BC. You draw segment BP in, so you want to draw this segment from B to P. And that angle, that whole angle is 62 degrees. Can you conclude that the segment bisects angle ABC? Well, it's going to bisect this if these two are congruent to each other. And this one's 5, that one's 5, and that makes a right angle, that makes a right angle. So those two are congruent. And our reasoning here is going to be any point B or P that's on the angle bisector of an angle, or the bisector of an angle, is equidistant from the sides of the angle. So you're going to look up and use the angle bisector theorem. Actually, you're going to use the converse of it, but you're going to use that angle bisector theorem. .44 says find the value of each variable. They tell us V is a centroid, so that's a centroid of triangle RST. They tell us that TP, that's this whole thing right here, that whole median, because if that's a centroid, each of these is a median. That whole median is 18. Well, we know that this has to be 1/3 of the distance. That has to be 2/3. We're looking for X. So X is going to be 1/3 of, or 1/3 times the 18. That's going to give you the answer to X. Again, remember, if you're multiplying by 1/3, you can use your ABC button on your calculator, or if you're multiplying by 1/3, you can just, it's the same as dividing by 3. Segment MS, that's this segment, across here, is 15. We want this segment up here, which is the shorter of the two again. So we're just going to take 1/3 of the 15, and that's going to give us what Y is. Segment RN, that's this segment, is 24. That's that whole median there is 24. We want the shorter segment again. So we're going to take 1/3 of, or 1/3 times 24, and that's going to give us Z. Next one, 45. Find X if segment EG is a median of the triangle. Well, if this is a median, then that tells us G has to be a midpoint. And if G is a midpoint, that tells us that these two segments have to be congruent. And all we're doing is trying to find X. So 5X minus 17 has to equal 3X plus 1. I'm going to let you solve that. That's going to tell you what X is. That's going to be your answer. I'm not sure why I have 2 blanks there. It should just, because all they asked you to find was X, there should just be 1 blank there. Next one, same thing. They tell us this is a median. That means U is a midpoint. If U is a midpoint, then 2X plus 24 has to equal 5X minus 30. last ones. I'm just going to do one of these for you. All you got to do on these, you're just trying to decide whether these can be the sides of a triangle. You're going to take any two sides. So this one I'm going to take 103 plus 41.9. That should be greater than 62.5. We'll check this out here in a minute once I get all of it written. Then I'm going to take 103 plus 62.5. That should be larger than the third side, which is 41.9. Then I'm going to take 62.5 plus 41.9, and that should be larger than the third side, which is 103. If all three of those check out, then yes, it can be a triangle. If one of them doesn't check out, then you can stop right there and say, no, it can't be the sides of a triangle. So on this first one, 103 plus 41.9, I know 103 plus 41.9 is going to be larger than 62, so that one checks. 103 plus 62 is going to be larger than 41.9. This last one, maybe, you can grab your calculator and check it. 62.5 plus 41.9 is 104.4. That's larger than 103, so that checks out. So yes, those can be the sides of the triangle. If you come to one that doesn't work, then that means that those numbers can't be the sides of the triangle, of a triangle, and you just write no over here in your blank. Hopefully that helps you, and I will let you know about the Chapter 6 test. That'll be one of the next things that you're doing. And it will just be a take-home test.